Hey everybody, Joe here. Gonna check out a puzzle today by yttrio that I've been checking out a couple times now. I ran out of time once and I failed it hard once. So we try it again. The rules are normal Sudoku rules, that's 1 to 9 in every column, row, and 3x3 box. Yin Yang is shade some cells such that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or fully unshaded. Small numbers in the corners of cells are internal X-sum clues. The digit in a cell with a clue gives the total number of cells, including itself, of the same shading as itself, seen in all horizontal and vertical directions combined. Cells of the opposite shading block division. Those cells sum to the number given by the clue. Digits may repeat within a sum if allowed by other rules. That's all the rules. So if you were to look at the 245s here and ask, can they be the same color? We have to say no. And the reason is because if they were to go fully across, then they would both have to be 9s. These would have to be a different color. They both have to be 9s. Alternatively, if one went like this, if one is like a partial and goes down, and one is a partial and goes down, then if they were the same color, then it would create a 2x2 here. So these two are therefore different colors. And this cell, being a 46 cage, cannot be just this entire column, right? So there is going to be a change of color along this cell, or I mean along this column. But there is also going to be, off of this 43 cage, you can see that it cannot be looking toward both edges. It can either be looking at one edge or no edge. But if it is looking up and to the right, it's going to either create just a section that will never get out of a different color, or it's going to have to take that cell too and become a 2x2, and we can't have that either. So there's going to be a swap of color somewhere over here, or continue to be pink, and then there's going to be a swap of color in this column, because this has to come out at least one. Now, since this is 45, it cannot also go all the way down, because then it would wall off some pink in here. Now I lost my train of thought here. Oh, right. Okay. So, what this means is, if this is yellow, this has to go up and around. Because when it swaps back to pink, since we have pink on this side, then it cannot swap back to yellow again. Because if it did, then there would be a yellow section up here, and when this pink section connects to this pink section, it's going to wall it off, and it won't be able to ever touch the other. So once we have our swap of color along this column, and it will, because it has to take this cell, and it cannot be 10 cells long, wherever it swaps back to pink, it will have to remain pink for the rest of the perimeter. Because you can only swap, like we start here at pink, we can swap to pink, but then, swap to yellow, but then when we swap back to pink, we can have no more swaps. So hopefully that makes sense. So yellow has to come around, well, it'll come to at least there, and then since we know that there is a swap on this column somewhere, because this entire column cannot be yellow, because then it would have to take this and it would have to become 10 cells. So we know that at least this one is pink, and when it swaps back to pink, it must go all the way back around. Therefore this is yellow, and this is yellow, and these at the highest are 987, which is 24, and then we would need 21 more, and this would be 65 at the highest, which is 11, and we would need 10 more, so we would need at least 2 more cells. So yellow has to be at least this big in order to make 45 with the highest possible numbers. So therefore this is pink, and now we can ask, can this be yellow? And we know that it has to come out at least one. So if it was yellow, you can see right away that it's going to make a wall for purple. Purple will never be able to meet its buddies. So this is pink. It does have to get at least one cell. And it has to come on down. These two have to be yellow. You cannot have a checkerboard either in a yin yang, or else it's going to eventually cause the same kind of thing where one section is closed off from the other. So whenever you have two on one side and you're about to make a checkerboard, like if you put pink there, that is what I'm calling a checkerboard. You cannot do that. So when you have two on one side, you just have to round it around. So that is that. We could say 987, even if we had 965 would be 20 more. That would be 44. So we need at least one more to make 46. So that one is yellow, this one is pink, we cannot make a checkerboard, and that one is yellow. So that is what that section starts off like. A 45 is at 6, 7, 8. So it is at maximum 8 or 9. This one is finished, which is 8. This one, if it was 9, 8, 7, it's 24. 6, 5, 4 is 15. That would be 39. It needs at least one more. This must be yellow. That is a 7, 8, or 9. But also, you can see that we cannot speculate 9, 8, 7 here. So if we were to ask if this can be a 7, and if we put the highest digit on here, and we said 9, 6, 5, 4, 9, 6, 5, 4 is 15, that's 24, plus 7 is 31, plus 3 is 34, we're at 34, we need 11 more, so we would have to take 2 at least, so it cannot be 7, so we have made an 8-9 pair there. $33, this is 6, 7, or 9. If it is 6, then these two are pink. This doesn't help me out too much. Oh, if this is yellow, if that is yellow right there, this has to be pink, and then this would have to be yellow again, and that would be 8, 9, 10. So that one is not yellow. If this was 7, it would be, if this was 7, this would be have to be pink, this would be pink, this could not make a checker, this could not make a checker, this would be yellow, this would be pink, this would be pink, this would be yellow, this would have to meet its buddies, as with that. It seems like it might be all right. That is 9, that is pink, then that is pink, this cannot be checkered, where did I go next? Oh, this, 30. This 30 cannot be pink, because if it was, and it had to see in some direction, then, if it took one step in either direction here, it'd make a 2 by 2. But to get to 30, you'd have to have at least 4 oh, wait a minute. I'm missing something. I'm missing a step over here somewhere. Oh, it's this one, isn't it? That is 8. Right. This is 8, so that is 9. So this one must have another pink. So this one is blocking the vision. This one is pink to avoid the 2 by 2. This one is pink. This one is now no longer 6, it is 7 or 9. And now, I can say this one cannot be pink. And because, back to what I was saying earlier, it would make a 2 by 2 here, or it would need at least 4. And if it took 4 that way, then it would create a 2 by 2. Either here or somewhere in there. So this must be yellow. And now I think we can ask if this was 9. Maybe it's still too early for this step. I can't quite remember. Yellow. 8 goes down here. $30 has to be at least, well, it has to be more than 4 cells actually. Would it even if it had to be like that? 9, 9, 18, 26, 30. Maybe if it was 9, 9, 8, it could have a 4 on it. Can be 30. If this was 2 through, no, let's not do that. Let's not speculate that high. This 43, if this was entirely made up of yellow, and you left the smallest digits out of it, 1 and 2, you would be at 42. So you would need at least one more yellow, and if you were to ask it this way, if you had these 4, then you would definitely need more. If it was 9, 8, 7, 6 is 30, you would need 13 more. So you need at least 2 that way. Now this is pink. Pink could be 311. So if we just speculated that right quick, and you can see these would have to be yellow, this would have to be yellow, this would have to be yellow, this would have to be yellow, and then this would have to be pink, making a checkerboard, which we cannot do. So that is not, pink is going to go, it's going to be a 2, and then it's going to be with a 3, either here or here. So if it went down, then this one and this one would be yellow, and then we cannot make a checker board. We cannot make a checkerboard here. This would be avoiding a 2 by 2, as would this yellow, and then we could not make a checkerboard here, but in turn this being yellow would wall into the pink, I mean. So this does not go down, but it goes this way, and now those two get blocked off with yellow. And now I think what's the time we can ask, can this be 9? This would be pink. This would have to be yellow. This would have to be pink. And then you cannot make a 26 in 2 blocks. So that is indeed 7. This does get blocked by pink. Avoid checkerboard, avoid checkerboard, avoid 2 by 2, avoid checkerboard here. That gets a yellow to avoid 2 by 2, and here yellow to avoid checkerboard. This is now pink. This is now yellow. Avoid checkerboard. Avoid 2 by 2. Now yellow needs to come out to its buddies all the way. This 26 has been made into 5 cells. 1, 2, 3, 4, 5. This 30 at the moment is seeing 5. So it must get at least one more. This is avoiding 2 by 2. This is yellow getting out to its buddies. And yellow is now 7, 8. So that goes like that. Yellow needs to touch here. This is now 6, because that's how many it sees. This is 4 or 6, because it currently sees 4. It cannot stop 5, because it's going to automatically pick up the 6. So it is only 4 or 6. And either this one or this one will be yellow, depending on that. Oh, the 2 went with the 3. And this 16 was also 3. And What else was there? Um, in this 30, so whatever these two are, well, actually, what am I trying to say here? So they need to be higher than 15 because this entire row has to equal 45. And in order to do that, it has to be at least 15. But if it was exactly 15, this box would still be 0. So it has to be higher than 15. So it has to be at least 16, which will require a 9. And we can't make any higher than that in 2 cells, because 8 is already in the row. So this being the maximum of 16, now this entire row is 46, and if you add up the numbers 1 to 9, you get 45. Okay, so since those are 16, we need this is 29, so this must be 1. And this box had 13 more to go, which can be a 7, 6, it can be a 8, 5, or a 9, 4. And that is it. From the way these are all looking down and occupying the box, etc. Those are the only way around those can all go. Now, 3 goes in one of these. It becomes part included in the 26 box. This cannot have a 9 here. The highest this could be is 768, 876, 21. If this was 21, or no, wait, this is 15, which means that these 5 are 18 left over, right? Because all of these cells here equal 33. So if you take 15 out, then just these cells are 18. And if we were to ask, well, if we were to max these two out and say it's 6, 7, 8, that would be 21. And then 21, and then this would need 24 minus that would need 17. So these four equal 17. But these 5 equaled 18. Therefore this is 1. And 1 goes up here. And with this cage, not cage, but, well, in effect it's a cage, kind of, except numbers can repeat. But within this line of yellow, this is a really high number for 6 digits. Even if we had a double 9, which is 18, a double 8, which is 16, that's 34, this is 40, we would need a 3. Even if we had double 9 and double 8, and 6, we would still need a 3. So therefore it cannot have a 1, and it cannot have a 1 now on any part of that line, any part of that yellow. This is the 1 now. These oh right, these were maxed out, don't forget, and we had to, and seeing as how if we went lower, then this wasn't going to have a fill because that barely made it with 1, then that had to be 6, 7. I just forgot to mark them in. And if we were to take this big pink strip, we know this whole row is 45. So if these are, if the total of yellow is, I think it was 8. If the total of yellow is 8, these two cells right here, then this would be 37, and then this would be 9. So this has to be, in other words, 8 or less. Which is 1 or 2. There. If it's 1, or wait, actually, if it's 7, then this is 38, and that would be 8, which it cannot be. So this is 9. This has to be 8, I'm pretty sure. If this was 8, this is 8, this is 37, and this is 9. If this was 7, this was 38, and 8, right. So this has to be 8. So it's either going to be 6-2 or 7-1. 2 cannot go in the middle here because there's no room for it up here. So it goes there. There will be another 9 somewhere in pink. So that'll be 18, 26, 20 more, and 5 cells. That doesn't seem too far-fetched. This was 17. Oh, this is 3, 4, 5 left over in this entire row. And this yellow could not have a 1 on it, so the 1 goes there. The 1 cannot go there. The 1 goes in one of those. That's a lot, though. Hmm. Three goes in one of these. 2 as well. One, 2, 3, 4, 5, 7, 8, 9. These are all 7, 8, 9. The ones over there. The 4 no, I don't think I'm ready for this one yet. If this was a 6 though, these cells, 5 cells, would be 18. It's a bit complicated since some can repeat though. So it could be, well, maybe not. The lowest number that could repeat, if this was a 6, is 4. And that would be 14. And you can make 10 more in 3 cells, I suppose. Well, no, you couldn't. If this was 6, and you had a repeating number, it would have to be 4. So it'd have to be like here, and then somewhere along the column. And then the 3 numbers to make 10 more would either be 127, which it cannot be, because of the column 2. 136, which is 6 would already be there. 145, which the 4 would already be there, or 235, again 2 is in the column. So you can't have 5 repeating. You couldn't have 6 there again. So nothing could be repeating if this was a 6. So these would all be actual different numbers. So 5 digits equaling 18 is 1, 2, 3, 4, 8. So this would be the 2. Well, actually, that one wouldn't work, obviously. It would have to be 1, 2, 4, 5, 6. This would be the 2. And then you'd have 1, 4, oh wait, sorry. 18 in these 5 cells. No, I did that wrong, my bad. So 1, 2, 3, 4, 8 would be 1. The 2 would go here, and this would be 1, 3, 4, 8 in some order. Or 1, 2, 3, 5, 7. Again, the 2 would go here, and this would be 1, 3, 5, 7. So I guess that would work. So if the 6 goes here, the 2 goes here. And then you have you would have 1, 3, 4, 8, or 1, 3, 5, 7. So a ton of numbers. If the 4 went here, if the 4 went there, you need 20 more in 3 boxes. 20 more in 3 boxes. It cannot be 3, 8, 9. It cannot be 4, 7, 9, because the 4 would be there. And then nothing could go there. 5, 6, 9. So 5 would go here. 6 would go there. 9 would go there. Five, 7, 8 would not work. Okay. Those are if you had all different digits. Now, can you make... We couldn't double any digits with if it was 6 here. Could we if it was 4? 20 more. In 3 digits. It would have to be at least a 6. It would have to be a 6 with an 8. Seven. Oh no, it can't be 7, 8, or 9. Okay, so that's all those can be. I know these are a lot, but that 2, 6 is helpful, I think. Maybe. Hopefully. But again, these pencil marks down here are only if this is yellow. If the 4 went here, this is not a 2. If the 6 goes here, this is a 2. Okay. Okay. Elsewhere. If this was maxed 8, 7, and this was maxed 9, 8, 8, 7 is 15, 9, 8 is 17, that's 32, that's 38, this would still have to be at least 5. It can't be a 5. And that was these. Does it work the same way going this way? If this is 9, 8, and this is 9. Oh, I guess that would be doing the same thing though. Nine, 8, 9 is 18, 26, 32. This would have to be at least 12. Maybe an 8475. Or higher. If I dropped any digits on this side, this side would have to go up. So this side maxed out was 998, 18, 26, 32. This would be 12. This would have to be 84 or 75. This or higher. So we could put in the, I think that would give me though every digit. If this side was maxed out at 87, and then this side was maxed out at 98. That'd be 15, 32, 38. This would need to be at least a 5. So this side, well, so it's not maxed out. But look, I don't think I could go up. If this 4 went up to a 5, well, it can't. This 4 can't go up to 6. This is 4-8 or 5-7 only. It can't go any higher than that. But it can't go lower either. Or could it? Well, I can't have a 3 in there. Can't have a 2 or a 1 either, so no, it couldn't. And that was if it's 12, 18, okay, let's try this. 12. Let's try maximum. 12, 9, 8. That's 29. $35, 8. So could this been 4-7? Yeah, I think so. So it could have been 11, 9, 8, 11, 17, 28, 34. That could have been a 9. And then I did 12, and then 15 with 9, 8, 32, 38, 5. So 15, with 16. 15 with 16. 31, 37, 6. 15 with 15, which it can't have. So this is not 8, 7. It's 5, 7 or 4, 8. Or could it be 4, 5? 9, 15 plus 18, or plus 17 rather. 9, 15 plus 17 is 32 plus 9 is 41, so no. So this is only 7, 5 or 8, 4. Okay. I think that's enough brainstorming on that for now. That hurt. So 6 goes down here. Okay. What is left? If that was 17, that was 23. There would have to be 20 here. Do I have 20 there? That could be 9 and 11, huh? Or 8 and 12, right. If it was 9, 7, 22, do I have 21 there? But I can't use 8, 7, right? Because it was 8, 7. It's 21. That would be 9, 30. This would be 13. So no, I couldn't. Can't be 8, 7. So if this was 9, 7, that'd be 22. We need 21 more. And the highest we can get there is 12. Well, that would be 21 with a 9, wouldn't it? So 9, 8 is 23. This needs 20. Be 11 with a 9, or 12 with an 8. So I guess the question is 8, 7. 21. Can I make 22? 12 is the highest. No, I cannot. So it must have a 9 on it. Which means this does not. Whoops, I deleted the wrong number there, I think. That does not. Does it have to have a repeat? If these were 9s, 18, 24, could these have 19? And yeah, it could have 12 and 7, or 11 and 8. I guess these could repeat over here as well. Okay, but I think for now, that's probably pretty good. Whichever one goes here. Seven or 8. I'll go in one of those, won't it? I don't know if I know which one though. I don't know if that's telling me that 9 is locked to one of those. Alright, so let's look elsewhere. This is 12, 13, 14, 15, 24. This needs 21. Oh. Without a 9. 21 without a 9 is 876. So that's what that is. 876. So therefore this is a 4. That had to be 13. Now this is a 7. That is a 9. That is not a 7. Six, 7, 8 leaves a 2, 5 down there, which means 5 must go there. So 7 goes there, 8 goes there, 6 goes there, 7 goes there. Very nice. 9 now goes there, out of necessity. Whoops. 9 could go here or there. Well, actually, we have 12, 27. We need 16. So this has to be 9, 7. Oh no. Oh yeah, yeah. I was about to say 8, 8. But since they're on the same column, that's a no-no. But do have to be careful with the double double digit possibilities on this fight, that is for sure. On this fight. This music had me thinking. Sorry about that. This is a 2. That equaled 8. That is good. If memory serves. This is going to be a 3, 4. This has to be a 4. This is going to be a 1, 5, 9. The 9 can only go here. That is a 1, 5, therefore. One, 2. What is this? That sees a lot of numbers there. 1, 2, 4, 5, 6, 7, 8, 9. That's only a 3 or 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, or 9. This is also then a 6 or 9. Okay. So 2. Oh well. It's already known that 2 goes in this column, but I didn't have it marked all the way. 2 goes in one of these. Four is down here somewhere. And so is 7. Not in the middle though. And 9 is in one of these. Is this only 2 9? Let me just fully mark the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2, 4, 5, 6, 7, 8, 9. That is it. Not as much as I hoped. I was hoping to make a combo wombo there. Did not happen. Alright, so what else? We get any more help with this 24, I wonder. I have no idea what the combinations were anymore. If it was 6, this had to be a 2. We're at 8. We need 16 in 4 digits. Wait, what? If this is a 6, this is a 2, and then we're at 8, and we need 16 more in 4 digits, and that's only... Oh wait, no, I'm thinking of 5 digits. Okay, 16 and 4 digits. What do we got? Cannot have a 2. A 1, 3, 4, 8. Suppose 1, 3, 4, 8 is still doable. 1, 3, 5, 7 still doable. 1, 4, 5, 6 is a no. because the 6 is already there. 2, 3, 4, 7. No. So 1, 3, 5, 7. 1, 3, 4, 8. 1, 2, 5, 8. Not 1, 2, no. Ah, dang it. What numbers was it? It was 1, 3, 4, 8. Or 1, 3, 5, 7. And that's it. 1, 3, 4, 8. 1, 3, 5, 7. If it was 4, then it was 6. And then oh wait. Oh yeah, because two numbers couldn't equal 18. So if it was 4, it had to be 6. 10. And these two were 14. Which would be 8 and 6. Oh, right. Or 1, 6, 6 and 8. Oh, right. That is the same thing. So it's 8, 6 here. Or 1, 3, 4, 8. Or 1, 3, 5, 7. Oh, that's kind of ridiculous. Ridiculously confusing, for sure. Is this any combos being made here today? 1, 3, 4, 5, 7, 8. 1, 3, 4, 5, 6, 7, 8. 1, 3, 4, 5, 6. No. Not even close. Not even close. So either 6 goes here, or this is 4 and this is 6. So this is not 6. This is 3. Two. Oh man, almost. Not quite. 9 goes on the... Alright, we gotta get 9 over there. Defeat 8. Okay, what are we doing? What are we doing? What are we doing? What are we doing? What about this guy? This is 8. Well, this is... what? 1, 3, 5, 6, huh? Let's just do it up. And there we go. We have a single... Oh, it's not 1, 3, 5, 6. It's 1, 3, 5. But it is a different number, which is a 4. So that is a single 4. This could have been a 5 though. It's 1, 3, 1, 3, 4, 5. Yeah. Alright. Well, that will equal 46. So I think maybe I think about this string of numbers going down that way. And this, I mean, it can only be, it'll have to be from a small number. Well, that's a little bit ridiculous. If this is This is 8. Actually, it'd be hard to have a 5 here. If this is 13, 16, that wouldn't work, would it? Oh wait. Let's not do that. Let's say if this is 8, these two need to be 9 more. If this is 5, 3, these two need to be 9 more. Can't be 8, 1, can't be 7, 2, can't be 6, 3, can't be 5, 4. So none of those will work. 5 does not work with 3. If 5 was 4, these would need to be 8 more. It couldn't be 7, 1. It could be 6, 2, couldn't it? If this was 5, 4, 9, this would need to be 8 more. It could be 2, 6. Could not be 7, 1. Could not be 5, 3. Okay. That seems right. If this is 1, with 3 is 4, and this would have to be 13. And it can't be, because 7, 8, 9 are there. 1 will not work with 3. If this is 1, 4, it's 5, it needs to be 12. Oh, it can't be 12 either, because 7, 8, 9 are there. So this must be 5. And this had to be, I think I said it didn't work with 3, because that would need to be 9. Yeah. So this is 4, 3, 1. 1 is over here, so 1 is over here. 3 is over there, so 3 is over here as well with 1. Five is over here. 5 is in the middle. Oh wait, no, 5 can go there. Make sure I look at all of my pencil marks, not just a few. Oh, although 5 is up here, so 5 must go down here, and one of these two. So 5 must go over here. A 6 is spoken for here. So is this a 2 or 4 then? I believe it has to be. Oh, right. Oh, well, no. Five will be here. This cannot be 5 then. What else do we got? Oh, we're almost there. I feel like I'm doing a lot better this time. As I haven't ran out of the room cursing and screaming. So that is always a boon. One, 3. Let's see. How do I come to the realization? Oh, this one maybe. 26. We have 15. We need 11. The only way we can make 11 is with the 9-2. That will definitely help things out. Now this is 6. Now this is 4. Now we got it. Now this is pink because 4 already sees 4. This is yellow to meet up with its buddies. And now I think I can find something new to get stuck on. This is now 6. This is now 8. This will be a 2-5 combo wombo. Oh, and since this was 4-6, this had to be 8-6, right? It's 10. It equals 14. So yeah. That is 8-6 therefore. Oh, these are no longer possibilities. I mean, they still are, but a 1 will go down here. What's left? It's a 3, 5, 7. 3. Well, let's just mark them all. 3, 5, 7. And then take out what we don't have. This is running pretty low too. This is a 4. In the column is a 4, 7, 9. And this can only be a 4. So these are this is a 7, this is a 9. Because of Sudoku, that is a 5. So now we had a 3 up there, the 1 and the 7. 3 there, 1 there. This is now a 4, this is now a 5. We get our 5s there in the middle column with a 1, 3. And my music stopped, but that is okay. Almost done anyway, I think. Perhaps. This is a 4. What's left here is a 2, 6, 8. 2, 6 is gonna go there by Sudoku, and an 8 is gonna go there. This has a 4, 3. This has a 2, 6, which there's a 6 above it. Get some of that done. This is a 8, 6. There's a 6 above it. This will do that. There's a 1 here, a 3 here, 4 here, 3 here, 1 here, and I think that will do it. That was a fun puzzle by yttrio. That one really had me stumped for 3 attempts now, I guess. This is my 3rd attempt, I think. So, which kind of made the first part a lot faster than usual, even though it still took an hour and a half almost. Hope you enjoyed. Please like and subscribe if you enjoyed. Check out the puzzle for yourself below. Internal Exum Yin Yang by yttrio. Nice one. Thanks a lot. Have a good one. Bye bye.